And hello, today we'll be looking at algebra, operations and notation. You should already be familiar with the fundamentals of algebra and how we use variables in different contexts. But today we'll be looking at how we actually use the operations on algebra. So what do I mean by operations? I mean addition, subtraction, multiplication, division. And how we might use them in different contexts and the notation that is involved with algebra. So I probably have mentioned this before, and you might have heard these names before, but this is important to know the names of things. So let's say we're given 5x minus 3. So first off, if we were just given a number in an equation, so remember an equation is when you have an equal sign, but let's say we're just given a number like minus 3 plus 3. It doesn't have to be a whole number, it could be a half, pi, it can be any number that's just a number. It's a given number, it's told to us. That's what we call a constant. So it stays the same, it doesn't change. Then we have our unknown variable. So again, the reason it's called a variable is because it can change. So if I let x equal to 1, so x is 1, well in that case it would be 5 multiplied by 1. So that's 5 minus 3, so this would be 2. But I could also let x equal 5, and that would be a different answer. If I let x equal 20, that would be a different answer. And when we have equations, we're looking for one particular answer. So then that's what we call the variable. The number in front of a variable. So sometimes we have 5x or half x or 3x. That means 5 multiplied by x. Now we don't bother writing the multiply sign just because it would take up a little bit of space. So instead we just write 5x. And this is what we call the coefficient, the number in front of x. So 5 would be the coefficient of x. These things altogether are called terms. So 5x would be one term, minus 3 would be another term. If I had plus 7y, that would be another term. These individual bits are called terms. So it's important to know these because I'll be referring to all these different names throughout the lesson, so you have to know what they are. Okay. As I mentioned before, 1x plus 1y, we just write that as x plus y. We don't bother writing the 1. Again, that's 1 multiplied by x plus 1 multiplied by y, but as you know, 1 multiplied by anything is just itself. So if I had 1 times 100, that's just 100. 1 times 10, that's just 10. So if you see x plus y, that just means 1x plus 1y. X plus x, we can write that as 3x. So that's the same as 3 times x. But remember, multiplication is just short form for addition. So if I had 3 times 3, that's just 3 plus 3 plus 3, which is 9. So x plus x, we can just add these x's together. So that would be 3x. What about 2 multiplied by b multiplied by c? Remember, we don't bother writing the multiplication bits, so we just say 2bc instead. Now, just note, these are all different. B is not the same as c, and 2 is a constant. We'll see later on where if we have things that are similar, we can multiply them together. But in this case, they're all different. 2 is a constant, b is a variable, c is a different variable, it's a different letter. So we can't multiply, well, we can multiply them together, but we have to keep them the same. So 2bc. Last thing, if I had 2 times b times c times 3. Now in this case, okay, I still can't, it's just b times c, but I have 2 multiplied by 3. Now I know the way 3 is at the end, but it doesn't matter. You can swap these all around. Multiplication, it's like addition. You can swap 2 times 3 is the same as 3 times 2. So 2 times 3, that's equal to 6. And then I have times b times c. So this is equal to 6bc. So in this case, I can actually multiply the two constants together but then I am just left with the variables multiplying each other. So you have to know all these different notation, these different kind of rules. I'll go through them again quickly. X plus y, that's just 1x plus 1y. X plus x, we can add them all together and we write it as 3 times x. 2 times b times c, we don't write the multiplication sign, we just write it as 2bc. But in the case where we have, let's say, two constants, we can multiply the constants together. So in this case, it's 3 and 2. So we can get 6bc. So yeah, this is all really important. You gotta be comfortable with all this because these are the easy questions. They only get harder from here. So let's say we had this. Simplify these expressions. So we heard about equations. Equations have an equal sign. Expressions don't have an equal sign. So how are we going to simplify this? So the big note here is you can only use operations on like terms. So what do I mean by like terms? Well, this is what I mean. You got to remember this now. This is really, really important. In this case, 2p plus p. See, there's a p here and there's a p here. I can add these p's together, kind of like the x's a minute ago. I can't just say, oh, 2p plus 3q. Well, I can't really add the q and the p together. They're not multiplying, so it's not 6pq, they're adding. I can't really add the r to the p. I can only add the same variables to the same variables, or subtract the same variables from the same variables. So in this case, 2p and p, I can add them together. Oh, I can add the q and the q together. I can do the r and the r together. So this is what I did. 2p plus p, well, that's equal to 3p. So I just added the p's together. Then I'm going to look at the q's. So I'm forgetting everything else. 3q minus 4q. So if I had 3 q's and I take away 4 q's, well, I'll have minus 1 q left. Now again, we don't write the minus 1, we just write it as minus q. Then I look at the r's. Minus r plus 2r. Well, that's going to be 1r, but again, we don't write 1r, we just write r. So my final answer, if I simplify this, so simplify just means make it smaller, well, I get 3p minus q plus r. I can't do anything else to this. I can't add a p to a q. I can't add a q to an r. That's as small as it'll get. Here's another one. 6x minus xy plus 5x minus 7xy. Now, you're probably tempted, oh, there's an x here, I can do it away. But it's xy. It's a different thing. X. Now, I can use those. X and xy are different things. That's really important. Xy is x times y. 6x is just 6 times x. So the variable here is just x. The variable here is xy, which is a different thing. So I'm going to add my x's. 6x plus 5x. So I have 6x plus 5x, that's 11x. Then I'm going to add my xy's. So I have minus xy minus 7y. xy. So I have minus 1 xy minus another 7 xy. So if I have minus one thing and I minus another 7 off it, it'll be minus 8 xy. So the final answer, if I simplify this, it would be 11x minus 8 xy. So here are some recap questions. Simplify, make this smaller, and find the mistake over here. Okay, so here's the answer. I have constants. I have xy's. I have a y. So, you might note as well, I have yx. Is that the same thing as xy? Well, yeah, it is. Because remember, xy is just x times y. Yx is just y times x. It's the exact same thing. 2 times 3 is the same thing as 3 times 2. I can swap the xy around, doesn't matter. So first off, I have my numbers. 2 and 3. So 2 plus 3 is 5. The constants. Xy. Now I know that's yx. I can swap the y and the x around, doesn't matter. So I have 2xy plus 7yx. Well, that's equal to 9xy. Or I could write it as yx. Doesn't matter. xy, yx, whatever you like. In this case, I just chose xy. What about the y? Can I do anything with this y by himself? No. So it's just 9xy plus 5 minus y. That's my final simplify answer. So the thing to know from this is yx and xy, they're exactly the same. They're just multiplying each other. If I swap them around, it doesn't matter. Addition and subtraction does matter. So just be, addition doesn't matter. So 2 plus 3, I could swap them around, wouldn't make a difference. Subtraction matters and division matters. Where is the mistake? So I have 2ac minus 4b plus 5bc. I got 2ac plus bc. Well, what they did was they said, oh, I can subtract 4b from 5bc. So that's just going to be bc. But that's wrong. Because look, we have bc here and b here. They're different things. b times c, this is just b. So I have 4 b's over here. I have 5 b times c's. I can't interact these two together.